Ref, that's a trip. What are you doing? Why are you tripping my players?
Hey, watch it, coach.
Okay, come with me.
Hey, hey, what are you doing?
Put the ball away.
What are you doing? Hey, bro.
I'll teach him not to trip my players.
Penalty kick.
Good thing that referee decided to finally call the trip. Now we get a free kick and I'm going to put in my best player, Aubrey.
Oh darn, another physics assignment? Quest! That's crazy. You kicked that ball at 37 degrees at 22 meters per second. This goal is only 3 meters high. Of course you're gonna go over it. There's only one way to know. We gotta use physics. What? I said using physics!
Alright everyone, this is the All or Nothing Unit 1 quiz problem. And it reads, a ball of mass 0.7 kilograms, initially at rest, is kicked directly toward a fence from a point 30 meters away, as shown above in this very well drawn picture up here. The velocity of the ball as it leaves the kicker's foot is 22 meters per second at an angle of 37 degrees above the horizontal. The top of the fence is 3 meters high. The ball hits nothing while in the air, and air resistance is negligible. Probably pronounced that wrong. And up here is the picture. As you can see, 22 meters per second velocity, 37 degrees above the horizontal. The fence is 3 meters high, and it gives you a little bit of information also, so you don't have to use a calculator. It tells you that to assume that the sine of 37 degrees is equal to 0.6, that the cosine of 37 degrees is equal to 0.8, and the tangent of 37 degrees is equal to 0.75. And the very first problem that it wants you to do is to find the initial velocity in the x and y directions. So this is what we call splitting the components. So you have a 22 meter per second velocity, like this, 37 degree angle, right? So this is the velocity in the x direction here, going like that, and this, when they meet up, is the velocity in the y direction. And to find that, we need to use the trig functions that they so very nicely provided for us up here. So, to find the velocity in the y direction, we'll go ahead and do that first. The y direction is opposite of the hypotenuse, so we need to use the sine trig function here. So the sine of 37 is equal to the opposite velocity in the y direction over 22. And we know the sine of 37 is 0.6, I believe is what it said up there. Let's double check. Yes, the sine of 37 is 0.6. So you're trying to solve for the y velocity. Multiply 0.6 times 22 to get your y velocity, and that will get you 13.2 meters per second. So that's the first part of this problem. Next, they want us to find the x velocity. So the x velocity, as you can see from the picture, is the adjacent side to the hypotenuse. So we need to use the cosine trig function, which is equal to 0.8 up here. So we write out cosine 37 is equal to the velocity in the x direction over the 22 meters per second. And we know that the cosine of 37 given to us is 0.8, and 0.8 times 22, solving for the velocity of x, is equal to 17.6 meters per second. So that's part A done right there. Pretty easy, huh? All right, so next they want us to determine the time it takes for the ball to reach its highest point. So now we need to start using kinematics. And to figure out which kinematic we need to use, let's write down all the information that we know about the problem and what we're trying to find. So it says determine the time it takes for the ball to reach its highest point. All right, so in order to do that, we need to start using kinematics. And to figure out which of the 4 kinematics that we need to use for this, we need to write down all the information that we know about this problem. So, because it's trying to reach its highest point, we know it's going to be in the y direction. We don't really care about the x direction in this certain particular problem. So, in the y direction, we know that the velocity is equal to 13.2, because we just solved that in the last problem. That's v1. The ending velocity, well, it's just not going to be moving, so it's 0. And the acceleration due to gravity is equal to -10. We're just going to go ahead and round to make this easy on ourselves. We do not know the time, which is what we are trying to figure out. So, which kinematic has velocity, distance, actually no, not distance, not in this one. My bad, I was looking at the wrong problem. Which one has velocity 1, velocity 2, acceleration, and time? That would be the kinematic v2 equals v1 plus at. Alright, so now we just need to plug in our numbers. So we know that v2 is 0. So that is equal to the velocity 1, which is 13.2, plus the acceleration due to gravity, -10, times t. So now you solve using algebra. It's pretty easy to solve. And you get t is equal to 1.35 seconds. And that is the second part of this problem. All right, so now the third part of this problem is to determine the time it takes for the ball to reach the plane of the fence. So we're just trying to figure out at what time will it get to that distance of the fence. So again, we need to use a kinematic here, and we need to find out which one by writing down all the information that we know. So we know that in the x direction, that our initial velocity, or v1, is equal to 17.6, like we solved in part A. We know that the distance is equal to 30 meters. The fence is 30 meters away. And we know that the acceleration is 0 in the x direction in most every kinematic, unless it tells you otherwise. And we do not know the time. So, what we're going to do is use a kinematic that has initial velocity, distance, acceleration, and time. And that kinematic is distance is equal to initial velocity times time plus 1/2 acceleration times time squared. So since we know that acceleration is equal to 0 right here, we can practically just cross this out because 0 times anything is 0. So we're basically just left with d equals the initial velocity times the time. So that gives us 30 is equal to 17.6 times the time. You divide 30 by 17.6, and you get the time is equal to 1.7 seconds. And that is how long it takes for the ball to reach the plane of the fence. Alright, so this is part D of the all or nothing quiz problem for Unit 1. And it reads, will the ball hit the fence? If so, how far below the top of the fence will it hit? If not, how far above the top of the fence will it pass? Alright, so again, we need to use a kinematic, and again, we need to write down all our information to figure out which kinematic we need to use. So, we're trying to find height here, so we need to use our y information. So we have y, and we know that the velocity, initial velocity, is equal to 13.2 from question A. We know the acceleration due to gravity is negative 10 meters per second. We're rounding to make this easier on ourselves. We know the time it takes to get to the plane of the fence is 1.7 seconds, as we found in question C. And we're trying to find the distance, which we do not know. So that kinematic is the same as the last one we just used, which is d is equal to initial velocity times time plus 1/2 acceleration time squared. So we plug everything in. D is equal to 13.2 times 1.7 plus 1/2 times negative 10 times 1.7 squared. Alright, so just plug all that into your calculator and you will get D is equal to 7.99 meters. Almost 8 meters. That's pretty crazy. Alright, so we know that the fence is 3 meters high. So in order to figure out how much it will clear, because obviously if it's going, almost 8 meters high and the fence is 3 meters high, it's going to go above it, not into it, as, I don't know, nobody would think. We will have 7.99. You subtract 3 from that, because that's the height of the fence. So the distance that will clear the fence is 4.99 meters. That's over. And the last part of this question, finally, is how fast will the ball be traveling when it gets to the plane of the fence? So this, again, is a kinematic question. And we will need to use both components here eventually, so keep that in mind. But first, so remember in the very first question how we had to split the velocity into x and y components? Well, we're doing the opposite here. We're finding the x component and the y component using the information that we have found throughout the problem, and then we need to combine them back together to get a velocity at whatever angle it comes down at, which we do not know, but we also don't need to find that, thankfully. So, start by writing down all our information. So we know that in the x direction, the initial velocity is 17.6 meters per second. We know the distance is 30 meters. That's how far away the fence is. That's how far it travels. The acceleration is 0. And we're trying to find the final velocity, which we do not know. And the kinematic that takes all of this information is the final velocity squared is equal to the initial velocity, squared plus 2 times the acceleration times the distance. Now again, since the acceleration is 0, anything times 0 is 0, so that cancels each other out. So the 2 squared is equal to v1 squared, which is pretty crazy. So we know that v2 squared is equal to 17.6 squared. Well, you take the square root of both of those. The ending velocity is the same as the initial velocity in the x direction.